This is Brent with Lykins Motorsports. This is our 496 FE for our forced induction build for Mr. Steve, and we're going to hop back on that today. Our goal for today is to get piston valve clearance checked, heads on, bolted on, and Mr. Steve has the rest of the parts, so we're going to wait on FedEx to bring those in the beginning of the week, and we should be able to button this up fairly quickly. But very rarely now do you have issues with piston valve clearance. This is why I've kind of waited till this part to check it. I was having these bars machined down so that they would accept the nuts for the studs, and that's why I didn't check piston valve clearance last week. But big old 50cc dish for our centrifugal hair dryer, and valve reliefs on top of that. So like I said, very rarely do I experience piston valve clearance issues, so that's why I went ahead and slapped all the pistons and rods in it. Piston valve clearance, everybody thinks that it's the lift that does it, but it's actually a combination of the lift and the overlap. Overlap causes the valves to hang open a lot longer than a short overlap cam would. So if you have a lot of lift and a lot of overlap, those valves are going to be sticking down for a lot longer than another situation. So it's not always the lift, it's the combination of the overlap and the lift. This cam has a little bit of both, but generally when I send an order in for a custom piston, I give them the cam specs, and they can map all that out for me. But we always check, right? So in order to check, we're going to throw a mock-up head gasket on. These are our BBM cylinder heads. These have been hand ported. Out of the box, BBM head will go about 280 CFM. These are quite a bit over that. I don't have the flow numbers in front of me, and I see a lot of heads. So if I had to go off my memory, I would say somewhere 320, 330 CFM, something like that. They have been fitted with Inconel exhaust valves, so we're going to be putting some boost through this motor, and we don't want to hurt the valves. Mainly valve springs. These are Next Tech. They've been polished and stress relieved, mainly titanium retainers, so all good parts. This is the T&D paired rocker system. The difference in this from a normal FE rocker arm system is that this bar is held on by the head fasteners. So they send head bolts with them, but we had this block honed, the cylinders honed with studs, and believe it or not, it makes a difference. And I did a little experiment at the beginning where I checked the roundness of the cylinder bores from the underside with bolts and with studs, and it does change the bore roundness by about a half thou. So always, that's another tip, always have your block machined with the fasteners that you're planning on using in the mains and on the heads. But this bar, you can see that the heads are machined down to accept this. This means that this is push rod oiling only, as this passage is going to be pretty much dead. And if you remember, I clocked the cam bearing so that there's no way that oil could come up there anyway. But this bar blocks that passage off. This bar goes here, the studs go through, and everything is clamped down, and then this bar bolts to this bar, and this is what your rocker arms bolt to. So this is a bulletproof setup for when we run solid rollers and valve spring loads, you know, up over 600 pounds. So first step is we're going to get a head gasket, and we're going to put some clay on our pistons and get our head mounted, and we'll get piston rolled over and our piston valve clearance checked. So here's how everything looks bolted up. I've got just a couple of studs in this thing to keep it clamped down while we roll the engine over. But this is how it all sets up. We have this bar that takes the cylinder head fasteners and clamps it down, and then you have this top bar that is held to the bottom bar by these fasteners. So very bulletproof. And then your paired rockers sit in these little grooves here. I guess, I don't know what you would call that, but sits down in that recess. And then they have 3/8 bolts or 5/16 bolts that hold those down. So I've got clay on my piston. We'll bolt a couple of rocker arms down. We'll get, we're using some Morel lifters. And we got our actual push rods that we can use. And we'll get our imprints taken. Okay, so the rocker arms are held down by these Torx head screws. Got our Trend custom push rods. Got one on the exhaust side, and we can just roll this over. Usually you can, if you got a checking spring on there, you can feel the valve hit clay. With this much spring load, you're not going to feel it. Okay, so we got the exhaust side done. So when you put your push rods in, remember the Evo method. So when I do the intake side, I will set the lash, because we want to check this with everything as it would be running. So we'll wait until the exhaust valve starts to open and then set our lash on our intake valve. Same deal here, intake side. Getting seasick yet? There's that valve starting to open. All right, so we should have a good imprint on both valve release right now. And we'll wait till that exhaust valve or lifter comes back up, and we'll take all this apart. All right, here are the results. You can see we have plenty of radial clearance on this eyebrow. Plenty of radial clearance on this eyebrow. But I don't know if you can see it. The valve opens so far above the piston that it doesn't even really matter. So we've got, I don't know, what, 3 miles of piston valve clearance. I will measure this with my calipers and just document it for future reference. But we are good to go on this, and if you'd give me a second to record some stuff and clean some stuff up, and we'll start getting these heads on. For this build, we are using Cometic head gaskets. I live out in the country. I'm around a lot of country people. These are not pronounced Cometics. While we're on that subject, it is not Edelbrock, it's actually Edelbrock. I don't know, pet peeves. But Cometic head gaskets, the pistons are about 3 thousandths down in the hole, so this will give us about 43, 44 piston to head clearance. One thing that you will hear bounced around the internet is that forced induction motors don't care about the quench distance. I would disagree with that. I think an efficient, naturally aspirated engine is the same as an efficient forced induction engine. So I don't subscribe to the throw a 60, 80, 100 thousandths head gasket underneath of it. Quench is quench. So in most builds, I usually aim for anywhere between 38 thousandths to maybe 50 thousandths or so. Try to keep it in that window. This one's going to be down, like I said, around 43, 44, so we're in good shape. On a Ford, the hole, you notice there's a hole here, there's no hole here. The hole goes towards the rear. Chevrolets don't matter. Fords matter. If you put this on backwards, you'll have a cooling problem. Kinetic head gaskets need everything to be clean and the deck surface prepared a specific way. And now we're going to get the cylinder head on. I do not advise putting all the head studs in and trying to slide the head down over the studs. If you do that, you will more than likely shave some aluminum off as you are sliding that head down. It is best to locate the heads, set it down on the block with the dowels, and then just screw in each stud individually. We've got our head slid over our dowels, and one thing, when this head gets milled, it leaves this little counterbore down here that has to be filled with a washer. And you ultimately want a washer that's got a thickness of about 2 or 3 thousandths thicker than that recess, so that when you torque everything down, you get a good clamp load on the head. But now we can put our bar on and get our studs going. Heads are torqued on. So we're in good shape. On these kinetic head gaskets, pay attention to where these rivets go. On small block Fords, they are even more oriented, not correct. You'll see them hanging out this side and they want to rub the timing cover and such. If the rivets contact a part of the engine, then it's best to drill them out so that the rivet sticks out on the top and the bottom. And if this tab is leaning against something else, it could cause the gasket not to seal. Next thing we need to do is get these rocker arm mounting bars on. They just sit on here, and then they're held on by these 12-point bolts. So we'll get some ARP lube on those and get those torqued up. All right, both of our rocker arm mounting plates are on and torqued. I torqued these to 65 pound-feet. Made my mark when I went back over them. Now is a good time where I can fit the intake manifold and just see if the flanges need to be cut. I'm going to do that. And then the oil pan and the rest of the components are on the way. So before the intake goes on, you guys know the ritual, prime the oil pump. And so in preparation for that, I'll go ahead and put all the lifters in, get them greased up and oiled up, and get our rocker arms on, push rods cleaned up and put in, and the last set, so that when the oil pan goes on and the oil goes in, I can prime the pump, make sure that I get enough oil to everything. Got our intake manifold on with no gaskets. Can you see that? I doubt my camera will focus my phone. The ports line up at the roofs exactly the way that they should, with no gasket. So that means the intake's gonna have to be cut 60 thousandths, the thickness of the gasket on both sides on the flanges, in order for the intake to sit the way that it should. This is a Victor FE intake. It's been ported along with the heads. Steve's gonna run a multi-port fuel injection. He's gonna send me the fuel rails and some old injectors so that I can plug these holes, but we're gonna dyno it with a carburetor. All right, now that that is done, like I said, I can go ahead and grease up my lifters and clean my push rods, put my rocker arms on, get everything set up in preparation for priming the oil pump. Now we're using Morel solid roller lifters on this build. Solid roller lifters with push rod oiling, and a lot of times they don't push enough oil. They actually meter down inside. Had this discussion on the FE forum the other day. Somebody said that they didn't like push rod oiling. with FEs, and I don't know why that particular person didn't have any experience with them whatsoever, but one of the points that was made is they push too much oil to the top end. That is well, it's just wrong. The lifters meter, the push rods meter, and you generally do not see any more oil to the top end over a properly restricted shaft mounting system, shaft oiling system. As a matter of fact, I anticipate on having to groove these two holes after I prime the pump, because most of the time they just don't push up enough oil through the push rods. So that's an easy fix, but I'm not going to do it until we are able to prime the pump and see what's going on. So I'm going to get these lubed up, slid in the bores. We've got our push rods all cleaned up. These are custom trimmed 3/8 heavy wall, and we'll get everything buttoned up. And here is where we're going to end up. All the rocker arms are on. These bolts that hold the rocker arms down to the sub bar torque at 25 pound-feet. I've already went through and set all my lash cold so that I don't have to do that again. We'll get the intake cut. Oil pan will be coming this week. We'll get that on, the pickup on. This engine will use a front motor mounting plate that will locate off of, let me see, probably the water pump holes. So we'll have to get some studs and put those on, then our electric water pump will go on. But sneaking up on it. T&D paired rockers, pretty beefy stuff. I've put a lot of RPM and horsepower through that with a lot of spring load, so sneaking up on it. Alright guys, this is going to be it for this build. Like I said, we'll pick up next week when more parts come in, but we're just probably 2 or 3 weeks away from hearing it run on the dyno. If you haven't subscribed yet, please do that. I'll have probably another video for you guys this weekend. Drag Boss Garage is featuring an engine that I built probably 5 years ago. There is a YouTube video of it on the dyno on my channel, but he's going to freshen that engine up and put it in his wife's car. But I thought it would be cool to talk about that build and go over the build specs and show some pictures from where it went together. So I may have that up this weekend. Hope you guys are having a good weekend. I will see you soon.